This video covers report period 1, week 6 homework for Spelman and Morehouse. I'm going to go over a few questions from each night. First, notice that on the second page of your homework this week, you have a reference page that will help you with Tuesday night's homework because we're working on converting different types of units. So make sure you're referring to page 2 as you work on pages 3 and 4. On Tuesday, we talked about converting units of length, area, volume, and mass. In the first question, you're simply being asked to decide if each is a measurement of length, area, volume, or weight/mass. For example, in question A, it says, how many centimeters are there across a handprint? In question A, we're using centimeters, and we know that centimeters is how long something is. If you can imagine what you would measure with a centimeter, you would be seeing how long a pencil is, a piece of paper, something small. Centimeters wouldn't tell you anything about the other measures. It doesn't tell you how much space something takes up, how much 3D space something takes up, or how heavy something is. So you would write that centimeters is a measure of length. For the questions in A, I encourage you to use your resources, like this page here. You see that centimeters shows up under metric length, so that can help you determine the length. You can also always Google these. In question 2, you're being asked to use the conversion chart to solve the following problems. It says that you can use a calculator, but you need to show your work. What did you type into your calculator? And label your final answer. I'm going to model question A. Question A is a distance question. We're being asked how many feet there are in 5 yards. So I'm going to scroll back up to my conversion chart, and I'm going to find the row that has yards and feet. I can see that 1 yard is equal to 3 feet. That means that there is 3 feet per yard. So I can write out my multiplication sentence. If I'm converting yards to feet, I know that I'm multiplying 5 yards times 3 feet per 1 yard. Since I have yards on the top and the bottom, it cancels, and I end up with the final answer of 15 feet. One thing to ask yourself when you're doing these problems is, does my answer make sense? If I know that for every 1 yard, there are 3 feet, that means that when I'm comparing 5 yards to feet, there should definitely be more feet than there are yards. This is just another way of creating an equivalent ratio, because I know that for every 3 feet, there's 1 yard. And I can set it up like this as well. If they're asking me about 5 yards, I know that I multiplied my number of yards times 5, so I need to do the same to feet, for a final answer of 15 feet. You'll always know what the original ratio is by scrolling up to the unit conversion table, because they tell you 1 yard is 3 feet, and all the other measurements that you're going to be asked about in this homework and in general. You'll always have this chart. It's not something you have to memorize. Finally, on Tuesday, you'll be working on question 3. Question 3 is similar to question 2, but we now have word problems. The directions didn't change. But let's look at A as an example. Tyler's height is 57 inches. What could be his height in centimeters? Again, you want to scroll back up to that unit conversion chart so that you can see how many centimeters there are for each inch, because we're working on a conversion between centimeters and inches. If we go back up at that table and we look for centimeters, is it not in the table? This could be a little tricky. Let's see. Looks like this one is not in the table, so Ms. Knez will have to add it as a note on the homework. I'll put it in here in the video, and it'll already be on your homework because I haven't printed it yet when I'm recording this. Let's see. So 1 inch is equal to 2.54 centimeters. So that means I can multiply 57 inches times 2.54 centimeters per inch. And my inches unit will cancel out. So I know that for 57 inches, I end up with 144.78 centimeters. And again, we need that unit conversion from the beginning to help us solve. And even though it wasn't in the chart, I will make sure it's in your homework by the time you're watching this video. That's it for Tuesday. So if you're pausing here, now's the time. Otherwise, I'm going to start going over a couple things on Wednesday night's homework. On Wednesday, we worked on problems involving rate, distance, and time because they're slightly different types of questions. In question 1, it says a train travels at a constant speed of 65 miles per hour per 7 hours. So we need to find out how far does the train travel. I always want to label this unit rate when it's given to me because I don't want to accidentally start dividing to find the unit rate if that's not what's being asked in the question. In this question, I know that for every 1 hour, I go 65 miles. And I'm going to be doing that for 7 hours in a row. So I'm multiplying 65 miles for every 1 hour, because it's miles per hour, times 7 hours. We're doing it 7 times, and hours cancels out. So I just end up with 65 times 7, and I get, a final answer of 455, and it's just miles because my other units canceled. So I'm traveling 455 miles as a final answer. Now, I want us to be really careful about reading these questions because number 2 is asking us for something different. It says a dog walker is walking at a constant rate. In 4 hours, so that's the time, she will walk 10 miles. How fast is she walking? When we see a question like how fast, that usually means they want to know the unit rate, the something per something. And that makes sense because unlike question 1, where we had miles per hour, in question 2, that rate was not given to us. They're asking us to calculate it based on the combination of time and distance that we know. So if we're looking for the miles per hour, we know that we need to split up the number of miles we know, which is 10 miles. And we're dividing that into 4 hours. And so none of our units cancel. There's no canceling of units. And we just end up with 2.5 miles per hour. And if you think through what that means conceptually, that makes a lot of sense because if you can imagine her walking the dog, in 1 hour, she goes 2.5 miles. In 2 hours, she gets 5 miles. 3 hours is 7.5, and 4 hours is 10. So you can see that if she was walking 2.5 miles every 1 hour, 2.5 miles per hour, she in fact would end up with 4 hours, 10 miles. So what I'm trying to get at here is that reading the question and being super clear on what the question is asking is a really important part of Wednesday night's homework. I want to give you one quick hint on 5. We're definitely going to go over this in class, but I want you to remember that when you're calculating rates, you need to make sure that you're using the same units of time and the same units of distance. If you need to pause there to think about what I said, you can pause. You need to use the same units of time and the same units of distance. And what I mean by that is you can't compare kilometers per minute to meters per hour. You're going to have to do some conversions like we did on Tuesday's homework. That's Wednesday. I'm heading on to Thursday if you need to pause the video. Thursday's homework is a quick review of unit price. Remember that unit price is the price per one. So So when I ask you for unit price, I'm asking you to find the price of one object. For example, in question 1, a farm lets you pick 3 pints of strawberries for $12. So 3 pints for $12. To find the cost per pint, I'm simply dividing the cost I know, $12, was split between 3 pints. And so we know nothing cancels, and we just end up with $4 per pint. That's unit price. Unit price is always the cost per one. In question B, they're actually asking us to flip it though, because they want us to tell them how many pints we get per dollar. So instead of the cost per pint, this time they are asking us for pints per dollar. And this here, what they're asking for, it's a unit rate because it's a per one, but it's not. It is not a unit price. And the reason why it's not a unit price is because it does not tell us the cost of one. It just tells us the pints per dollar, but we can still find it with the same steps. We divide 3 pints by $12. And again, the reason why the division flipped is because the words flipped. We were looking for cost per pint, and now we're looking for pints per dollar. 3 divided by 12 gives you 0.25 or 25 cents. Oops, not 25 cents. See, we got to be straight with the units. 0.25 pints, so 1/4 of a pint per dollar. And I'll let you do C and D. The only other question I want to show you on Thursday is just question 4. In question 4, it says Noah bought 15 baseball cards for $9. Assuming each baseball card costs the same amount, answer the following questions. There's a hint here I just want to draw your attention to. It's find the unit price first. They're going to ask you about the cost of different amounts of baseball cards. And we've been talking a lot about how when you know the price of one object, it makes it easier to make comparisons or to answer any sort of extension question about the problem. And so in this case, when you're being asked to find the unit price, remember that that unit price would be the cost per baseball card. So you want to kind of do that off to the side before you solve for A and B. And you're using the same steps I just demoed in question 1, but I wanted to make sure to highlight that note. That's it for this week's homework. We got a short week this week, so make sure that if you have questions, you're checking in with me before Friday.